Welcome to In 5 Minutes. We take problem on deflection of beams and we consider simply supported beams. Our problem statement is find deflection of point C for the beam as shown in the figure. So we have this loading diagram of the beam. This blue line represents the line of the beam and it has one force which is downward and magnitude is 2000 Newton at point B and a clockwise couple of 1500 Newton meter acting at point C. Point A and D are its supports and these forces are at distances as shown in the figure. So first note down all the given data. So we have a simply supported beam and the value of flexural rigidity EI is not given, so we will assume it to be some constant and we will try to determine the parameter in terms of EI. And in the problem we have been asked to find the deflection at point C, that is Y at C. So let's solve the problem. So we start with the solution. Our first step is to determine the support reactions. So let VA and VD be the two support reactions at point A and D and we'll assume it to be upward. Of course in the problem it was given upward only. So by making use of static equilibrium equation we can determine the two unknown support reactions. So first we make use of summation about any point is equal to 0. So we consider the point A. So we can write summation of moment about point A is equal to 0. Now writing the equation for moments of all the forces about point A, we have our sign convention is clockwise moment is positive, anti-clockwise moment is negative. So we have a clockwise moment due to the downward force of 2000 Newton which is acting at a distance of 2 meter. So we have 2000 into 2. Then there is a clockwise moment of 1500 Newton meter. So plus 1500. And we have an anti-clockwise moment due to the assumed upward vertical support reaction VD which is acting at a distance of 7 meter. So we have minus VD into 7. So this is the algebraic sum of all the moments about point A and this is equal to 0. So upon solving this we get the value of VD as 785.71 Newton. Now since the value comes out to be positive, our assumption is correct, that is this force is upward. Now let's make use of another static equilibrium equation, that is summation of Fy is equal to 0. Now we'll consider all the vertical forces. Our sign convention is upward forces positive and downward forces negative. So we have VA plus VD minus of 2000 Newton is equal to 0. So upon substituting the value of VD from this, we have VA plus 785.71 minus 2000 is equal to 0. So we get the value of VA is equal to 1214.29 Newton. Since the value is positive, we have this force as upward force. Our next step is to write down the bending moment equation. Considering point A as origin, let us take a section XX across the beam at a distance x from the origin and move the section from point A to other extreme point D. Now writing the bending moment equation about section XX of all the forces and couples in one single equation, that is by Macaulay's method. So we take a section XX across the beam and we start from point A and move the section towards point D, towards right. So let the section be between point A and B which is at a distance x from your origin A. Now if you have to write the bending moment about XX, now considering the left hand side of the section, we can write MXX which is also equal to EI d square y by dx square is equal to, there will be a clockwise moment due to the upward force VA. So we have VA multiplied by x. Now this equation of moment will be valid when a section is between point A and B. Now as you move your section towards right and beyond point B such that your section XX is now between point B and C and at the same variable distance x from point A. So we see if you write the bending moment considering the left hand side of section about section XX, we see that this equation is not valid due to the presence of this downward force of 2000 Newton at point B. So let's put this equation in your first partition, meaning that this part of the equation is valid between A and B only. Now writing the bending moment about section XX when it is between point B and C, we'll see that clockwise moment due to this upward force VA, which is at the same distance x, so it will be VA into x, minus of, there will be an anti-clockwise moment due to this downward force of 2000 Newton, and now which is acting at a distance of x minus 2 meter. Now we see that this bending moment equation will be valid between point B and C. Now let's move this section again towards right beyond point C, such that your section is between point C and D. Now if we write the bending moment equation about section XX, now we'll see that these two terms will remain same, whereas there will be only addition of this clockwise moment which is acting at a distance of x minus 4 meter.